We have had 2 talks on synthetic diamond. Now we're going to go back on the natural diamonds and actually to the last 2 talks on sort of unusual locality diamond. And the first talk will be given by Hui-Ying Loke, also known aka Sarah. That's a little easier for a Western mouse. And she'll talk about the rare diamonds that come from Myanmar.
Thank you. Good morning, ladies and gentlemen. Thank you to IGC for having me here this morning and putting me as the second last speaker of the whole conference. Makes me really nervous for the whole time. Yeah, but it is my privilege and pleasure to present to you diamonds from Than Lwin River near Mong Hsu, Myanmar. And this research project is done in collaboration with the National University of Singapore and also the Department of Geological Survey and Mineral Exploration, Ministry of Natural Resources and Environmental Conservation, Myanmar. So I'll be sharing on our what we use, our materials and methods, and also the samples and results of our analysis, as well as our discussion and conclusion. So as an introduction, we acquired 16 rough diamonds in 2023 from a dealer connected to Mong Hsu, Shan State. And from this area, Myanmar's diamond finds are mostly small, alluvial, with no confirmed primary source or headless places. So this has been recorded in a few other literature as well. And you can see over here the picture of 16 pieces of diamonds. Historically, most of the diamonds from Myanmar has been reported from Momek, Tonggu, as well as Than. So this has been also recorded in various literature as well. So over here you can see in the slightly north central part, which is the Momek township, is alluvium deposits, as well as the Tonggu township with alluvium deposit as well. Over here is the southern part of Myanmar with the Than alluvium deposits. And what we are showing here today is from here where it is in the Mong Hsu township. All of these deposits are alluvium in nature, and our study aims to characterize diamonds using basic instrumentation such as microscopy, UV, Raman, and FTIR. So the 16 rough diamonds, as you've seen just now, weigh from 0.18 to 1.02 carats, total of 7.86 carats. The general morphologies, we see octahedral, trioctahedral, tetrahexahedral, mecal, and rhombic dodecahedral shapes. Our instrumentation includes a GIA standard binocular microscope, as well as a UV ultraviolet lamp, Raman spectroscopy with a 532 nanometer laser, and FTIR spectroscopy. As an overview for microscopic observations, we see on the surface and internal features brown and green radiation spots, which generally imply exposure to radioactive environments, as again has been reported in other literature that mentions about Myanmar diamonds. Also percussion marks that suggest mechanical impact in the alluvium transportation. Over here, you can see hexagonal edge pits and trigons and a few other edge pittings that we have in our samples. One of them looks like a two-phase, edge pits. So this these edge pits and lamellae on the far right side may suggest also plastic deformation and also mechanical impact in etching. In our Raman spectroscopy results, I'm just going to show a few of our readings. So all of them show strong peak at 1331 centimeter minus 1, which confirms diamond structure. And because I was working with the National University of Singapore Chemistry Department, the lecturer took out their graphite sample and we actually make a quick comparison for the students to see, and it was very clearly different. There are secondary peaks as well. As you can see over here in our sample number 6, the picture of sample number 6 is right over here. With this reading is taken near to the inclusion right here, and we see a peak at 1442 as well as 154. And this is not the only one. There are one or two of the pieces that has these peaks. So we see that it may indicate, disordered carbon around that inclusion, as well as lattice stress. So for this sample, which is sample number 13, we see a 1419 peak over there. So this reading was taken near to the growth structure of this diamond, and it may indicate also the plastic deformation in this case. And last but not least, with sample number 11, you can see all these green spots, as well as some percussion marks with green coloration within the percussion mark itself, and some brownish coloration over here. We see peaks at 381 and 1216, which may indicate radiation damage. So this reading is also taken at those areas. With the FTIR spectroscopy, we find that all the diamonds, 16 pieces only that we have, they are all type 1A AB materials. And we see the A aggregated nitrogen peaks right over here, as well as the B aggregated nitrogen peaks over here. Also, number of pieces, number of the samples we have at the hydrogen-related absorption bands as well. So this may indicate long mental residence. It's been in the ground for a long time, and there may be like a secondary growth process that happened to the diamonds. For ultraviolet lighting, we can see over here there are mainly faint to strong fluorescence, and out of the 16, we have 3 really strong ones, as you can see over here in the pictures. I'd like to, at this moment, thank our Singaporean, my Singapore staff in Singapore. They're watching on my video. And these 3 photos are actually taken by our boys, teenagers, from my son's school. And they are here with us as an attachment. And they have kindly helped me to take these photos. So I just want to thank them for that. And they did quite a good job for just being 4 days in our place. So here are the photographs of the strong fluorescence of these individual diamonds over here. So they may indicate also linked to all this radiation effect that has been that has happened on these diamonds. So there are some diamonds, 2 of them, in fact, inert responses. Well, I write over here low nitrogen, but I highly doubt so. Actually, I think it's more on I don't know, the absence of optical effects or something like that. They're inert responses, but not many pieces are like this. So for our discussion, based on our microscopy and Raman peaks, we see all those brown and green radiation spots. They are radiation-induced defects. It's not just like 2 pieces, there are quite a number of pieces that are like this, as well as pieces with percussion marks. Number of them as well, with this kind of a curved markings on the surface. And as you have seen just now, there are some that even has that radiation spot within the fissures or the percussion marks itself. So over here is a disordered carbon stress features near inclusions that's observed. Not many pieces have a lot of inclusions, mostly are quite clean. And last but not least, we confirm that out of all the 16 pieces, all of them are type 1A AB with natural defect history. And this is a summary table which you can see in the procedure booklet that you have. In conclusion, once again, this study aims to characterize diamonds using microscopy, UV, Raman, FTIR. What we have in Singapore at that moment of this research paper was a little bit limited. And we hope that with small amount of sample size, we can increase the sample size, hopefully. And that because they are all rough and not polished, we need to polish them, maybe make a window or something, and to do more substantial characterization to look at the inclusions with a Raman. and also, of course, with other instrumentation such as photoluminescence, cathodoluminescence, and UV-vis NIR, and inclusion analysis. So here is the conclusion that I have. Diamonds showing signs of radiation damage, plastic deformation, and stress, alluvial. They are mantle derived, most likely with some altered post-growth, and also with very strong indication that the main lattice has been preserved with the Raman as well as FTIR. So as mentioned, these are the future studies that we hope that we can do. And we want to acknowledge our support, our friends from Myanmar for supplying the diamond specimen and their kind guidance, as well as the scientific manager, Dr. Myanmar Kin from NUS with support with the Raman spectrometer. She was the one that helped us with all the measurements. And Dr. Linda with her knowledge as well. And Dr. Than Lwin from the Department of Geological Survey and Mineral Exploration in Myanmar with his help on the geological, the map, and also the understanding of the geological conditions of these diamonds. And last but not least, of course, to Mr. Tai San for his guidance, and my staff back in Singapore helping us while we are all here sort of enjoying ourselves, and my family members who are here listening, and all of you right here listening to me. Thank you very much.
Thank you. Okay, do we have a question? Yeah.
Thank you very much to see such a alluvial related diamond from the Myanmar. I see from the photo, seems like this diamond has experienced some naturally irradiated by this chemical solution underneath. And see the very heavily etching pit, even in the triangle shape or hexagonal shape as well. So it seems like normally diamond in alluvial layers have a more like you have some zircon or monazite, this kind of radiation element containing mineral to create this radiation. Then finally forming this green color for your diamond. So that could be some more than 10 million or more than that to have this kind of process to have this color.
Yeah. So actually, I think one of the things that we could do is to find out the indicator minerals, whether, surrounding the area, there are any indicated minerals, like for example, like you mentioned, zircon, right? So if we can actually also, I don't see many literature on that actually, not so much about the indicator minerals, but if we can have some information on that, I think we can, do more work on it. Yeah. Thank you.
Thank you, Eloise.
Thank you for this presentation. So two questions actually. One, did you look at the inclusions yet, or will you look at the inclusions to know what kind of diamonds they are, if they come from eclogetic suites or periodic suites?
So we didn't polish the diamonds. We tried to look at the inclusions. There are not many of these diamonds that we have that has inclusions near to the surface that we can actually observe. The one that we have is one of those that you saw in the picture. And it's quite difficult to get any information from there, actually. So what we would like to do is to make a little bit of a polishing for the diamonds and do more detailed study on whatever we have. Yeah, thank you.
And nitrogen and carbon isotopes as well, maybe?
Yeah, possibly if we can. Yeah.
Thank you very much for the presentation. A question. Do you think that these diamonds were exploited since very long time, like 2,000 years, or might be a source of ancient diamonds, what we call?
I think they are unscaled. They're not very long time. It's, I think, probably around about 30 years ago, from what I read. Yeah, 30 years ago. Which one? The map?
One slide that mentions the first discovery was followed by a geography of the diamonds in
Speak in the microphone.
1959.
Right here.
Speak in the microphone, please.
It's 1990s. They were recorded.
About 1950s. 1950s.
Lindo,
Yeah.
which is 1959. It was recorded.
Yeah, so also it's more than 30, maybe about 50 years ago. So it's
exactly.
it's unexploited, and they found a couple of hundred pieces Yeah. Mhm.
Thank you.
Yeah. Thank you.
Okay, well, thank you very much.
Thank you.
I should have mentioned actually that she's a co-founder of the Gem Museum of Singapore, an important thing, and does a lot of things with kids that you obviously mentioned.